So I'm going to do the homework for you. You correct yourself. 10.0.0.0. And there are 7 departments given, which means we have 7 subnets to create. We need to create 7 subnet out of this 10 network. And the mask is /8 by default. For 7, we learned in the previous class that we need to borrow 3 bits because 2 to the power of 3 minus 1 gives 7. 7 is the number of subnets. 3 is the number of bits that you're going to borrow from the host bit. So we are going to take this 3-bit for network. The balance 5-bit we are not going to take for network in that octet, and the other 2 octet is also available for host. So when we have 3 bits, the first option is 10.0.0.0, which means the borrowed 3 bits are 0. The second network will be 10.1 here and 00 here, isn't it? So the place value of this is 32. So 10.32.0.0. Next is 010. When it is 010, it's going to be 10.64.0.0. The reason is the place value here is 64. This is 32. This is 64. This is 128. The next is 011. So when it is 11, 64 plus 32 is 96. 10.96.0.0. The next is 100. 100, which is going to be 128, because here 100, the borrowed bits, the first bit is on. So 10.128.0.0. Next is 101, which is 128 plus 32, which is 160. 10.160.0.0. Next is 110. That will become 128 plus 64, which is 192. Next is 111. We don't use it. Which is 224. And put like this, wrong. We should not use this when all the bits, given bits are 0. We should not use it. Now, you see, this is the first network, second, third, fourth, fifth, sixth, 7 departments, 7 networks you have. And the mask for all this is, can someone say what will be the mask? You have given 3 bits from host. So what will be the mask, network mask? By default, it is 8. Now you have given 3 more. What is the mask? 11. You need to respond quick, please. 11. If you don't know, you can keep quiet or you can say don't know, but when you know, you should respond fast. The new subnet mask is 11. How do we write in another way? 255.224.0.0. The all 3 bits, network bits, and all 8 bits, network bits. So it's 11 now. The default is 8, but after subnetting, the mask has become 11. And now for the first department, the first IP will be 10.0.0.1. The broadcast will be 10. Can someone say the broadcast of the first network, first department? Exactly.
10.31.255.255.
10.31.255.255. And then the last will be 10.31.255.254. Likewise, for the next network, 10.32.0.1, 10.64.0.1, 10.96.0.1, 10.128.0.1, 10.160.0.1, 10.192.0.1. And the last of the second subnet will be 10.63.255.255. Sorry, that is the broadcast. This is called broadcast IP. You should not assign these broadcast IPs to any computer. If you try assigning, it won't accept in first place. Now, this is going to be the last IP. This is the first IP, right? I'm not going to write the last IP because only the last number will be 254. That is the only difference. So let's go to the broadcast again. Now, the broadcast of the third subnet.
10.64.
10.64 is the network. What is the broadcast? See the next network. If next network is 96, then it is 95.255.255. And the broadcast of the fourth network is 10.127.255.255. And the broadcast of this network, fifth network, is 10.159. And the broadcast of sixth network is 10.192.255.255. See, why did I write this one, though we are not going to use it, so that you will not make mistake when you write the broadcast of the seventh one. 10.223. How do I know? Because I'm referring to this one, and I'm saying it is 223.255.255. This is the reason we need this, just for reference. This is not a valid subnet. When all the borrowed bits are on, you cannot use it. You know why? Why? Because you see, this is given to network. For the host, you got only up to this 5-bit. With 5-bit, will you be able to make this 254? Sorry, 224? Not possible. Those bits, no, 224 and all, belong to this range. So that because that is already given for network, you cannot use it. Fine. So this is the homework. Hope you have written correct. If not, quickly correct it and let me know once you are done. We'll go to the next. I want to give a break for the subnetting because too much of subnetting is looking like a mathematics class. So we'll come back to subnetting after 1 or 2 days. We are going to get into interesting topic. I never did like this before for any other batches. I used to finish the entire subnetting, then go to the next topic. But for your batch, I don't know why I feel like this. Let's do something interesting, then we will come back to this mathematical topic. But before that, I would like to give you another homework so that you will not forget subnetting. You need to do this homework before you come next class. 192.168.0.0. 5 departments. And this is a little bit complicated compared to all that I have done in subnetting class for you. But try. When I do in the class like same like what I did today, when I do tomorrow, you will be able to correct yourself and be comfortable. So I'm trying to make your subnetting easier instead of pressurizing you in one single day or 2 days. I'm going to split it. We are going to get into small topics. First is ARP. Have you copied the homework sum? 192.168.0.0, 5 departments. You see, there's a protocol called Address Resolution Protocol, ARP. We won't find ARP in IPv6. ARP is in IPv4 alone. ARP, Address Resolution Protocol, is only in IPv4. Now, why do we need ARP? Or what is ARP first? What is ARP? What is the purpose of this protocol ARP? Address Resolution Protocol ARP. The purpose is to learn the MAC address of the neighbor. To learn the MAC address of the next device. Next routing device. To know the MAC address of the next routing device. Is a switch routing device? No. Computer is a routing device. A router is a routing device. And layer 3 firewall is a routing device, not layer 2 firewall. We also have layer 2 firewall. Layer 3 firewall is a routing device. ARP resolves the IP address into MAC address. ARP resolves IP address into MAC address. ARP resolves IP address into MAC address. So if you give this ARP protocol an IP address 10.0.0.1, it will go and find that computer whose IP is 10.0.0.1 and copy the MAC address of the computer and give it to you. This is your computer. In your computer, you are saying, I want to know the MAC address of 10.0.0.1. Immediately ARP will go and get the response. And now your computer's ARP table knows that 10.0.0.1 MAC address is AAA. We call this as ARP table. Let me show you my ARP table. But in offline, I cannot record this. We have seen how the MAC address looks like. But just for easy, as I have written AAA as a MAC address. But you saw MAC address is 12 digits of hexanumerical number. 12 digits, 12 numbers, alphanumerical number. For simplicity, I have written AAA. AAA. Now, we also saw a MAC address, all FFF, all 12F. We call it as layer 2 broadcast. Whenever you do not know whom to talk, you broadcast with this address. For example, this computer's MAC address is AAA, and your computer IP address is 10.0.0.2, and your MAC address is BBB. So in your computer, what you did is, you said, I want to talk to 10.0.0.1. For example, you are saying ping. I want to ping 10.0.0.1. See, if you want to ping, you need MAC address of 10.0.0.1. You don't know the MAC address, assume this MAC table is, the ARP table is empty. The ARP table is empty. Initially, it will be empty. But the moment you hit enter, your operating system will provoke ARP. It will send ARP request. And what will be the ARP request look like? It will have your own source MAC address, and destination MAC address will be 12 times F. I'm just writing 3 times. Now, when this packet goes and hits the switch will send the packet to everyone, whoever is connected. A copy that goes here will be responded by this PC, because this PC matches with the layer 3 address of this packet is what? 10.0.0.2 source. The source is 10.0.0.2. The destination is 10.0.0.1. The layer 3 source is 10.0.0.2. Destination is 10.0.0.1. So when this packet goes to this computer, because the destination address matches, this PC will say, okay, I'm going to respond. Yeah, it's me, 10.0.0.1. Let me respond. So when it responds, it will not be a broadcast. It will be a unicast. This was a broadcast packet. So it's sent to a layer 2 broadcast. When the response will go from source A to destination from where the packet was coming, from BBB. So it will go to BBB. What will be the source address? 10.0.0.1. To whom it is replying? This guy was the one who was sending. So it is replying to 10.0.0.2. When this packet goes, the ARP table get updated. 10.0.0.2 MAC address is A. So it learns from the response. We call this as ARP reply. Sorry, yeah, correct. ARP reply. This is ARP request. ARP reply. From the ARP reply, you'll be able to learn the MAC address. ARP request, ARP reply, ARP response, ARP reply. So you learn the MAC address. After this, only your original ping will go. In the real world, if you would have noticed, when you ping for the first time, 1 or 2 packets is getting lost. You know why? It takes time for the ARP reply to come and give the MAC address. By the time the ping gets expired, ping is packet internet grouper. Packet internet grouper. Ping is kind of testing the reachability, no? So it uses a protocol called ICMP, and the ICMP echo packets will be sent to the destination, and if the destination is available, you'll get echo reply, echo request and echo reply. Right, so we got ARP request, ARP reply, because ARP does a layer 2 broadcast to discover the MAC address. Once the MAC address is learned, only the ping packets will start going. So any conversation, without knowing the other device MAC address, you cannot establish. You need to know the MAC address of the other device. Obviously, IP address also needed. With the help of IP address, ARP dynamically discovers the MAC address for us. How? By doing layer 2 broadcast. What is the layer 2 broadcast address look like? How it looks like? 12F. 12 times F. Any question on ARP, the protocol ARP, the protocol ICMP? Any question? No, there's no acknowledgement
Is
for
there any
ARP or ping.
brother?
For ping,
Acknowledgement?
ICMP echo request is a request, and the reply is a kind of acknowledgement. But you should not call it as acknowledgement. It's an ARP reply and ICMP reply. We cannot call ARP reply as an acknowledgement. So there is no acknowledgement for this layer 2 broadcast, nor for that ICMP ping. Ping uses ICMP. Ping stands for Packet Internet Grouper. ICMP Internet Command Management Protocol, Control Management Protocol. ICMP. ICMP needs the MAC address. For that, ARP goes and helps. So you are not going to go and initiate ARP. When you try pinging, ARP will automatically go and get the MAC address, and ICMP will take the MAC address and use it. Not only ICMP, if you are trying to telnet to your router, your laptop will immediately initiate. See, when you telnet anyway, you are going to put the IP address. When you telnet, you will say, I want to telnet to that IP address. So layer 3 address is known to your computer. It needs to learn only the layer 2 address. Layer 2 address is learned through ARP. ARP. What is layer 2 address? MAC address. What is the size of MAC address? 48 binary bit size or 12 hexa decimal size. Hexabit size or alphanumeric hexabit size. Correct. Hexadecimal bits. 12. Layer 2 broadcast. Layer 2 broadcast is 12 times F. Next. There is another protocol called DNS. Domain name server. You see, in cybersecurity, or no need to go into cybersecurity, even normal security, if you are trying to protect your network, if you're trying to protect your network from unwanted websites, DNS can help you. Why? Without the help of DNS, no one can visit a website. Now, what do you understand by DNS? The domain name server is nothing but the server with a big directory in which the IP address of all the domains are saved. Domain name server is a big computer with big directory where for Yahoo, this is the IP. For Google, this is the IP. See, in telephone network, the manager 201, the assistant manager 202, phone extension. Likewise, in domain name server, for every domain, bbc.com is a domain. Do you know the IP address of bbc.com? No, but you have already visited the page. Facebook.com. Do you know the IP address of Facebook.com? No, but you have visited Facebook.com. How is that possible? Because your computer knows this DNS. Your computer needs to know only this DNS. Whenever you type facebook.com, your computer will go to DNS. Hello, DNS. what is the IP address of facebook.com? So for that, your computer will use UDP protocol. 53 is the port number. UDP 53 is the port number for DNS. UDP 53. It's not TCP based. So you are not going to initiate this like ARP. Did you initiate the ARP? No. You are trying to telnet someone or you are trying to ping someone. The ARP will go and do its job. Likewise, when you try to go to some website, immediately your computer will first go to DNS and ask, hey, what is this website? Do you know anything about this website? DNS server will give the IP address of the website that you are trying to reach. With that IP address, your laptop will go and now request the web page. So without DNS support, you will not know the domain name's IP address. Today, no one knows about any IP address of any domain, but we are all surfing net. We don't know the Google's IP address. We don't know YouTube's IP address. We do not know Yahoo IP. But then you are accessing without knowing IP address. It is because your computer knows the DNS address. This is universal DNS address. This is one big computer somewhere in the internet. This address. So when you type www.yahoo.com, your computer will generate a packet to this destination with this port number asking for Yahoo. And that DNS will respond with Yahoo's address, like 80.1.1.1. And then your laptop will go to 80.1.1.1 with HTTP request, which is TCP 80 port number. And then the web page will come to you. You see the role of DNS? It is to resolve the domain name into IP address. See, because you have DNS, your laptop need not to maintain the IP address of all the domains of this earth. It is not possible. Yahoo, every now and then they will change the IP address. That gets updated in DNS. It cannot get updated in your laptop. It's a very nice idea, no? You don't remember all the phone numbers, right? You go to where? You go to the contact, and then you just type the name that you to whom you want to call, and then you can see the number. And now you press the call button and it goes. Same. The contact list is what DNS. You need to know how to go to contact list. So what I was talking about what DNS is. It seemed like your contact list. If you know to go to contact list in your phone, you can easily find the phone number of mine. You don't really remember my phone number, but whenever you want, you can call me. Likewise, you don't need to remember the IP address of all the domains. Whenever your computer wants to request for a website from someone, it will go to DNS server and ask the IP address of that website, using which it will send a request of the web page and receives the web page. Let me show you an example. The command prompt. See, I do not know the MAC address, sorry, IP address of bbc.com. But you see, ping www.bbc.com. As soon as I hit enter, you start seeing the IP address of bbc.com. You see, 151.101.152.81. This is the IP address of bbc.com. Now let us go to that IP and request for web page. I'm going to type this IP address. This time I'm not going to type bbc.com. I'm going to say 151.101.152.81. 81. You see, it takes me to some web page. Look at this, www.bbc.com. But my firewall is blocking it. My firewall finds the website as a bad website. All right, so let's now try another website, www.yahoo. See, 27.123.43.204. Let's try that. See, yahoo.com. So you don't need to know the IP address of any domain because my PC is already configured to go to the DNS and get it. This is the DNS address. 8.8.8.8. If that server is down, it will try 4.4.8.8, another server for the entire world. Sometime in your computer, you will not see this. Instead, you will see your own router's address because your router will be configured with this. Your request to go to router, your router will forward it to 8.8. So depends on the network's structure. Did you understand DNS? Right. Now let us move on to another topic, DHCP. Dynamic
Yes, sir. Yes, sir.
host configuration protocol. Dynamic host configuration protocol. What is this dynamic host configuration protocol? The protocol that can go and assign IP address to every computer in your local area network. In a LAN. In a LAN, what is a LAN? Devices that belong to same network is a LAN. So you may be connecting like 40 computers to a switch. All these 40 computers, instead of you going one by one, turning, see, they all should be on, but instead of you going and sitting on every monitor, keyboard, and mouse and assigning IP and stuff, you manually assigning the IP address, you can connect one of the DHCP server. It can be a Cisco router that can act as a DHCP server, or it can be one of this computer acting as a DHCP server, whatever. In our case, let us take router. Now, as soon as this is coming up, this computer, as soon as the computer comes up, it'll get the IP address from here. That is why we call it as dynamically. The host has been configured with the IP address by this protocol. The IP address is dynamically given to the computers. But it will be given only to those computers that ask for it. DHCP server will not go and search for the computers and say, hello, computer, see, you don't have an IP address, fellow? Come on, take this IP address. No, no, no. That's not the way DHCP will work. DHCP server will not go and give IP address. These computers who needs IP address, they are called as clients. The client, when they come on, they send a layer 2 broadcast because they don't have an IP address to communicate. They send a layer 2 broadcast. That layer 2 broadcast is carrying the message asking, is there any DHCP server? Now, this guy only can respond because this is a server. This is, yes, I am. I can offer you this address. And the client will verify, okay, this looks like a fancy number. Wow, let me request for it. And then as an acknowledgement, it says, okay, granted, take it. This is how DHCP works. I repeat, the clients will send a layer 2 broadcast packet called discover. The clients will send. And that packet will be received by DHCP server. All will receive, but only DHCP server will process it because there is no other DHCP server. Why all are receiving it? Because it's a layer 2 broadcast. See, they don't have IP address. They cannot do any layer 3 communication. So it does layer 2 broadcast. Is discovery packet a unicast? No, it's a broadcast. Who is sending this? Client sending it to a layer 2 broadcast address. 12 times F. And now the DHCP server provides offer. Server is providing offer to the client. What is offer? Offer is not giving you IP address for granted. It says, hey, if you will request me, I will be giving you this IP address. Check whether you like this IP address. Something like that. Offer is not final one. Offer is simply offering. See, I'll give you this address. Is this okay? So client now checks that address and it says, it requests, client is requesting the server, yeah, that was very nice address. Kindly confirm for me. Then immediately the DHCP server will copy the MAC address of the client. After copying the MAC address of the client, it will say, okay, for this MAC address, I'm giving this IP address. So that is what called as acknowledgement. Acknowledgement is sent from server to the client. You see, 4 packets: discover, offer, request, and acknowledgement. Discover packet is sent as a layer 2 broadcast from the client. Offer packet is sent again as a layer 2 broadcast from server to client. Request packet is again sent as the broadcast packet from the client to the server. And acknowledgement is the packet sent from the server to the client, granting the permission to use the IP address. That's the acknowledgement. It grants. It says, yes, you can take it. And the lease period is 24 hours. For 24 hours, it will give the IP address. What if after 24 hours? After 24 hours, see, I give you IP address. And if you are using continuously, 24th hour, I'll renew the same IP address to you. Actually, you will request and I'll give you the same IP address. But after 24 hours, if you didn't request, then DHCP server will erase that entry from the binding table. So when you request after the 40th hour again, it's not guaranteed that you will get the same IP address. You may get another IP address, sometimes the same IP address. It depends. So DHCP is 4 packets: discover, offer, request, acknowledgement. Dora, Dora, you know, Dora, Dora. Dora is a cartoon show for kids in olden days. Not too olden, like 2000, 2001, 2002, I have seen. Children watching a program called Dora in television. Dora will show way to lion's den, to the vegetable garden. Dora, a tour guide kind of cartoon series. So you can use that. Remember this 4 packets: discover, offer, request, and acknowledgement by the name Dora. There are many people called as Dora. Some of my relatives called as Dora. It's a female name, Dora. Anyhow, remember this sequence: discover, offer, request, acknowledgement. Any question on DHCP? In our next class, I'm going to do a lab on DHCP. And then we'll go back to our subnetting.
No, sir.